This is the fourth Fundamentals of Misting video, Pressure Drop 201. We ended our intro to pressure drop video with this chart and a pressure engineering rule. Rule number 4. Don't install any more than 35 nozzles in a single run of 1/4 inch tubing, which seems clear enough. But what if I need to install 60 nozzles down a 600-foot fence line? We know 60 nozzles in series won't work, because the pressure curve looks like the purple line on this chart, with almost all the nozzles operating under 200 psi. It may be possible to place the pump in the middle of the fence and tee into 2 runs of 30 nozzles each, like this. The resulting pressure curve for each of the 30 nozzle runs, shown here in light blue, looks much better than the 60 nozzle line, but the middle of the fence isn't a very practical place to position the pump. Let's say the pump has to be at the end of the fence. How else might you approach it? Here's a hint. Consider using bigger tubing. This is 3/8 inch tubing, which is its outer diameter. In 3/8 inch tubing, the circumference of the inner wall is only 30% larger than 1/4 inch tubing, but there is 80% more fluid in 1 foot of tubing. That means that a smaller fraction of the fluid is touching the wall, and there is less friction for the same amount of flow, so there is less pressure drop. And the greater the nozzle count and the higher the flow, the more of an advantage the 3/8 inch tubing has. Recall the chart we developed in the previous video that showed how pressure drop in a 10-foot segment of 1/4 inch tubing increased dramatically with flow. Let's contrast that with 3/8 inch tubing. At 20 nozzles of flow, the drop in 1/4 inch was 1 psi. In 3/8 inch tubing, the drop is 0.5 psi. Not much difference. But at 40 nozzles worth of flow, the drop in 1/4 inch tubing is 3 psi, and in 3/8, it's 1 psi. At 80 nozzles of flow, the drop in 1/4 inch tubing has increased to 10 psi in a 10-foot segment. In 3/8 inch tubing, it's 3. Now go all the way to the last bar, 140 nozzles worth of flow, which represents the pump's capacity. In 1/4 inch tubing, the drop is 30 psi in 10 feet. In 3/8, there is only 6.5 psi of drop, a dramatic difference. Knowing this, let's go back to our fence. To take advantage of this phenomenon, we could run 600 feet of 1/4 inch tubing with nozzles spaced every 10 feet, and then for a pressure boost, run 300 feet of 3/8 inch tubing and splice it into the 1/4 inch tubing between nozzles 30 and 31, like this. Now let's add the resulting pressure curve to our chart, this green line. The 3/8 inch booster line gives it an interesting shape. The pressure at nozzles 1 through 30 are higher than both of the previous curves. And look at the dramatic difference the boost makes in the pressures at nozzles 31 through 60 versus the purple 60 nozzle run. While the last 15 or so nozzles on our boosted line are just marginally below our target minimum of 200 psi, it's certainly close enough to work on an installation. So here's rule number 5. If you have to put more than 35 nozzles on a run, use a parallel 3/8 inch line to boost the pressure at the middle of the run. We sometimes get asked, why don't you use 3/8 inch tubing everywhere? There are 3 major reasons. 1, it's just not necessary for the vast majority of installations, which average about 40 nozzles, and where it's possible to position the unit somewhere in the middle of the nozzle circuit. 2, the 3/8 inch tubing and fittings are much more expensive than the more commonly used 1/4 inch materials. And 3, the tubing and fittings are much larger and more difficult to conceal in the installation. Now you probably won't encounter too many straight 600-foot fence installations. Instead, you'll be trying to create a perimeter of protection around a property, typically a backyard. We'll talk about that more in the video that addresses laying out a real nozzle circuit around a property. Let's look further into this perimeter idea and see if we can draw some useful conclusions. Let's say I've got a property with a 600-foot perimeter made up of 4 150-foot sides in a square, and we want to install nozzles every 10 feet. If we place the pump in a corner and run 600 feet of tubing and 60 nozzles like this, even though we have a perimeter, we actually have 60 nozzles in series, and we know from our previous discussion that won't work. We could tee at the unit and install 2 runs of 30 nozzles like so, and you'll recognize this as 2 30 nozzle runs, and we know that will work fine from a pressure standpoint. And we also have the option of connecting the 2 runs and forming a complete loop like this. What will that do for us? Since the runs are identical in length and nozzle count, the pressure at nozzles 30 and 31 will be the same, whether they are looped or not. But now let's throw some real life into the scenario. Suppose our property isn't a square. Let's say it looks like this, and there's a koi pond in the lower right corner where we don't want to place any nozzles. We'll talk about that in a later video. So the nozzle circuit might look something like this. If we tee at the pump, we've got a run of 150 feet and 15 nozzles, and a run of 450 feet with 45 nozzles. This violates the 35 nozzles on a run rule. We could add 225 feet of 3/8 inch booster line like so, but maybe there's another answer. What will adding 50 feet of 3/8 inch tubing to close the loop in the nozzle circuit do for us? Like this. The answer is it will create a pressure profile that looks like this. The run that was formerly 45 nozzles now behaves as if it were 35 nozzles, and the run that was formerly 15 nozzles now behaves as if it were 25 nozzles. And we've only added 50 feet of 3/8 inch tubing instead of 225 feet. So by creating a closed loop, we've solved our problem. If you can tee the nozzle circuit close to the unit and avoid running more than 35 nozzles in series, you don't need to loop the nozzle circuit to ensure that all the nozzles operate above our minimum target of 200 psi. The advantage of closing the circuit into a loop is that you can sometimes add incremental pressure to some nozzles on the circuit by creating more balance in the runs which start at the unit. So to generalize this into a rule, rule number 6, try to loop the nozzle circuit if the nozzle runs from the pump are very different in length and nozzle count. Let's consider another situation. In some cases, it's not possible to position the unit close to the nozzle circuit, and there can be an extended run with the full flow requirements of the nozzle circuit. Take this example, where you've got a 40 nozzle circuit, but there is a 100-foot run from the unit to the tee. If you were to make that run with 1/4 inch tubing, you would have 65 psi of pressure drop, as shown here. If you make it with 3/8 inch tubing, you only suffer 20 psi of loss. That extra 45 psi can be meaningful in ensuring that the last nozzles in the circuit are operating over our target minimum pressure. So rule number 7 is, for runs greater than 30 feet with no nozzles, use 3/8 inch tubing instead of 1/4 inch tubing. So let's end this misting fundamentals video by reviewing the rules we've developed. 1. Adjust the pump bypass to produce 250 psi at the unit, never higher. 2. Each nozzle should operate in the target misting zone between 200 and 250 psi and mist 40 to 50 milliliters per minute. 3. Tee the nozzle circuit as close to the pump as possible and divide the flow. 4. Don't install any more than 35 nozzles in a single run of 1/4 inch tubing. 5. If you have to put more than 35 nozzles on a run, use a parallel 3/8 inch line to boost the pressure at the middle of the run. 6. Try to loop the nozzle circuit if the nozzle runs from the pump are very different in length and nozzle count. And 7. For runs greater than 30 feet with no nozzles, use 3/8 inch tubing instead of 1/4 inch tubing. If you follow all these rules, your installation will reliably create that blanket of protection you're after.